Hello, Dennis Madden here, and welcome to Gears Overdrive. This article was published in December of 2024. It's called Friction Dynamics. Shifting complaints from friction materials and fluid incompatibility they've always been around, going back to the early days when I was a rebuilder, but they're even more common today. And we have instances I've seen on the hotline like Hondas where you have a harsh shift complaint because the shop didn't use the Honda oil or something like the old torque shift, and they didn't use SP1 fluid, and it had shift flares and different complaints. So it's very, very important that you understand the fluid that the manufacturer recommends. But it's even deeper than that. Sometimes the friction materials themselves are inferior, and even using the OE fluid will not remedy the failure. So let's talk about that for a moment. Here's a small sample of friction material types. You can see the various colors, a light material here, sort of yellow, a tan or a brown. You'll also see lathe cuts in the material, some going toward the center of the plate, some in different directions. You can see waffling surfaces, a wide range. You can see other colors that I don't show here: red, green, blue. There are so many different friction materials available. The other thing that's important to recognize is a transmission manufacturer may get their plates from several vendors. So, for example, you may have a unit that has 5 clutch packs, and it may get 2 of the or frictions for 2 of the clutch packs from vendor A, 1 from vendor B, and 2 from vendor C. And if you were to order these from the OE supplier, they'd come from those manufacturers, or they should. So they're very specific when it comes to friction plate engineering, the dynamics of those plates and the requirements that they've designed that clutch pack to operate with. One of the common sources for transmission shift complaints is simply using the wrong oil. We've seen this with Hondas in particular are finicky about this. You can use Dexron oil in a Honda transmission and generate all sorts of harsh shift complaints. Chrysler is pretty touchy about that too. As a matter of fact, I wouldn't single out anyone in particular. They're all getting pretty finicky. And as I mentioned earlier, the friction plates are made by various manufacturers, and they have very specific engineering requirements for those plates and to work in the proper oil. And even something as simple as the torque shift. Many years ago, we saw all sorts of shift complaints by simply not using the SP1 fluid. One of the more common complaints we see with fluid and friction incompatibility is chatters. Now for this, I'd like to step away from automatic transmissions for a moment and just think about a standard and a manual clutch. So imagine for a moment that you have a brand new vehicle right off the showroom floor. It has a standard transmission, and you're going to go for a drive. You can operate the clutch pedal different ways. You can move it quickly, either to apply it or release. You can drag it so that the clutch slips and as you're shifting through the gears or from a takeoff. And that's one of the features that an automatic transmission has. It can apply or release a clutch very quickly or very slowly. The other thing that a standard transmission or clutch can do is it can vary the amount of torque it can transfer. That is a function of the clutch cover, the pressure plate, and the springs inside of it, how much force they apply to the friction disc and what it's able to transfer. Now, if you have some springs that break, as an example, all of a sudden it can't transfer the amount of torque necessary. But getting back to everything being perfect, here's the question. Is there anything you can do with that clutch pedal to cause a chatter? Now think about that for a moment. You're sitting there, you push the clutch in, you put it in first gear, you're about to take off. Is there a rate that you release that pedal that will cause a chatter? Well, you might think so initially, but the answer is no. All right, now you can slip the clutch, you can pop the clutch so that it takes off and chirps the tires, but none of those will cause a chatter. What will cause a chatter, though, is repeated misuse of the pedal, dragging the clutch as you release it, or resting your foot on it so that the force of the clutch cover isn't 100% and it's allowing the clutch to slip. And then over time, what will happen is you'll have hot spots on the flywheel and the pressure plate. The friction disc or clutch disc will get burn spots on it, and you've disrupted the surface of the friction and the steels, if you will, the flywheel and the cover. And now all of a sudden, the damage to the friction material and the steel surface that it rides on will generate the chatter. This is the same thing that is true with an automatic transmission. The friction material, if it's going to cause a chatter, we're looking at an incompatibility between the material itself or some damage with the material, damage, hot spots to the steel plates, and an element that's not part of a standard transmission, and that's the fluid that it operates in. And the reason why that is key is if all of those things were fine, it would not be a control issue. And that's where a lot of people want to go when they're dealing with clutch chatters, whether it be during a shift or the converter clutch, is they're looking in the valve body or they're looking at solenoids or computer-related matters to address that. And I go back to that standard transmission. If all those components are good, you cannot work a chatter into a standard transmission clutch by controlling the rate of the pedal. The same thing is true with an automatic transmission. I'm belaboring this point on purpose, all right? Because if you have a situation where there's a friction problem that's generating a chatter, you can apply the clutch faster and just push through it. It is possible. So back to the standard transmission. You have a burnt disc. You've got hot spots on your pressure plate or the flywheel, and it chatters when you take off normally. You can pull that pedal out or let that pedal come out so quickly that you push right through it and you're not feeling the chatter. And you can do the same thing with an automatic transmission. You can manipulate it to some degree in the valve body, but don't be confused about the fact that it's a valve body problem. No, chatters are specific to the friction material, the surface that they're riding on, and the fluid that they're working in. So let's keep those points very, very clear. Now, back to the standard, and it's such a wonderful example. So let's say that you have a standard transmission, and because of your driving behavior, like I mentioned before, you're resting your foot on the pedal so that the entire force of the pressure plate isn't on the clutch, or you're dragging the pedal out and you're heating up the friction material and you're damaging it to the point that this brand new car after 6 months now has a chatter when you take off because the driver has damaged the material. Well, you can apply that thinking to an automatic transmission, and this is where we see the rebuild goes out, it drives perfectly, and then all of a sudden, 3, 4, 5, 6 months later, the customer comes back with a complaint, maybe a converter clutch chatter, a chatter during the shift or one of the shifts, And this could very well be a control issue where the valve body was not delivering enough pressure to either the converter clutch or one of the clutch packs, the one that has failed. And over time, it has damaged the material. It's created hot spots. It's glazed over the material. There's some damage as a result of the low pressure or the shifting dynamics. And now over time, that damaged material comes back to the shop in the form of a chatter. And you may go ahead and do some valve body work and mask over it, but don't be fooled. As I mentioned earlier, a chatter is not a control issue. A chatter is a friction materials, the surface that it rides on, and the fluid that it works in issue. But you can create it over time with control matters. Now, I've belabored that quite a bit. I want to get into one final thing. I'm using an old example here from my old hotline days. I was... Many of the other guys didn't like working on KM175s. I thought they were rather interesting, so I got most of the calls. And let me pull up the chart here. Okay, here's the KM175 clutch and band application chart. It's a pretty simple unit. Came out in 1985 and was produced until the early 2000s, something like that. Now, I'm using this for a specific example, not to get into the oldies and talk about things that you're probably not seeing these days, but there's a very good lesson from this unit, and you may find something like this in the future, and so it's a very good point to make. Now, on the ATRA hotline, we would get a complaint of a harsh 2-3 shift every year for about 3 or 4 years. So there'd be a couple of months where we'd get this complaint, then they'd go away. And everything the technician did to soften the shift actually made it worse. And it's not until you understand and go through the process of what happens during the 2-3 shift that it becomes clear and you can understand the root cause of the problem. So let's take a look at this. So here we're in second gear. We have the band on, kick down brake, and the rear clutch, which is like a forward clutch, as I mentioned earlier. And now we're going to shift. Now there's 2 phases. The first phase is to release the band and apply the front clutch. And what happens in the valve body during this phase, this is when the shift is supposed to occur, by the way. What happens in the valve body is there's a mechanism in there that is based on oil flow, and the oil flow going through an orifice takes so much time for it to build up pressure into the valve train. And after a period of time, the valve strokes and the end clutch comes on. All right, so during the shift, and when the shift is completed, you're with the rear clutch and the front clutch. And then all of a sudden, the end clutch comes on. Now imagine, let me back this up for a moment. All right, so we've shifted there. Imagine for a moment that this front clutch isn't working right. It's shifting, it's trying to shift, it's sliding because of some malady or malfunction that's going on, and the shift is occurring. Now the shift is complete. It's still not fully applied when all of a sudden the end clutch comes on. Now the key to the end clutch application is it isn't metered one bit. It just slams on. And the reason is simple. If the shift is complete and the front clutch is on and the rear clutch is on, the shaft that the end clutch rides on, which is a long shaft going through the whole transmission, the frictions aren't spinning differently than the steel plates. The rate that clutch comes on is immaterial because you're not going to feel that application. So they don't bother introducing or including a system that is going to bring that on at any particular rate. They just snap it on. So if this front clutch was not able to complete the shift. By the time the end clutch came on, you felt the end clutch application, and because it's not controlled, it appeared in the driver's seat as a harsh 2-3 shift. So now while the technicians are over here messing around with trying to soften this front clutch, it made this matter even worse because the clutch was having an even more difficult time applying. The root of this problem turned out being the friction material itself in the front clutch. So there were friction plates coming into the US market that were inferior, and they wound up in many of the different rebuild kits, and they simply didn't work in this unit. They didn't, for lack of a better word, they didn't grab quickly enough. And so they slid through the shift until the end clutch slammed on, and that's what they felt. Now, we were able to get around it to some extent by, and it's backward thinking, by adjusting the valve body to firm up the shift, causing the front clutch to apply a little more aggressively and beat that end clutch. But the real cause of the problem, the root of it, was the plate. And when they went to a different manufactured plate, it fixed the problem. Well, once the parts distributors learned about this, they were very specific to the products that they were getting. And that problem went away until about a year later. Those plates wound up back in the marketplace. The complaints started all over again. And as I mentioned, this was about a 3, maybe 4-year period before it was really understood what was happening. And we've seen things like this many, many times. I can go through other stories where there's a shift problem, and I told the technician, hey, do you have the band, the original band? How does that look? Is it in the trash can still? Yes. They'd go get the old band, put it in the transmission, and by golly, the transmission would work great. Now, these were in the days where taking the transmission out was pretty quick and simple, and you can go through that. Those days are long gone. My point with this, though, is friction material is very specific. The fluid that it works in is very specific. Be very careful. Chatters are friction material, the plates that it works with, and the fluid that it works in. The dynamics of friction and fluid are very tricky, and so pay very, very close attention. This is Dennis Madden signing off to another Gears Overdrive. I'll see you later. Thank you.